Representation of Catalan's number. So we have been doing quite a few videos on Catalan's number now, right? We have already established a formula for electric current relation, asymptotic formula, some infinite series, and a lot of things, right? And in this video, we are trying to establish its integral representation. It can look a bit complicated, but it's not really that complicated to prove it. And we will be using this formula of Catalan's number 1 over n plus 1 central binomial coefficient, right? This proof is in the intro video, which I will link in description, right? You can check that out. But for now, let's go into the proof. What I'm going to try to do is I'm going to try to transform the central binomial coefficient, write this in terms of gamma function. And to be more specific, in terms of this gamma of n plus half. Because over here, we know this formula is root pi by 2 to the power 2n minus 1 gamma 2n by gamma n, right? So there's already this 2n and gamma n. And if I just divide this by one more gamma of n, I'm almost gonna have that central binomial coefficient, right? So this is how, and then later on we can transform this into integral, right? So that's how we are gonna find the integral representation of the Catalan's number. Okay, so this becomes gamma 2n by gamma n, right? And we know that gamma of n is just n minus 1 factorial. So this becomes root pi, sorry, this is 2n, root pi by 2 to the power 2n minus 1, and then 2n minus 1 factorial by n minus 1 factorial, n minus 1 factorial, right? Okay, so what I'm gonna do is I'm gonna multiply by 2 times n factorial, and also over here n factorial and into 2, right? So what that does is this becomes, okay, now also I think I need to multiply both sides by 1 over n, 1 over n. Wait, I'm doing the wrong thing. Okay, I'm just multiplying by 2n over here in numerator, not by 2n factorial. By 2n in numerator, and also n, and then 2 over here in denominator, right? And also by 1 over n in both sides. 1 over n in both sides. So what that does is, so now I have gamma n plus half by gamma n plus 1, right? And over here on the other side, now this becomes 2 to the power 2n, which is 4 to the power n, right? Now this is 2n factorial by n factorial n factorial. And this is exactly the central binomial coefficient that we are looking for, right? So this becomes square root of pi by 4 to the power n, and then 2n choose n. So now we know that this 2n choose n is actually 4 to the power n by root pi, and then gamma of n plus half by gamma of n plus 1, right? This also somehow shows that, I don't know, this central binomial coefficient is somehow related to power of 4, right? Okay, now but we know that this Catalan's number is actually 1 by n plus 1 to n choose n, right? So this becomes 1 by n plus 1 4 to the power n by root pi, gamma of n plus half by gamma of n plus 1, right? So that's why the central binomial coefficient, sorry, this Catalan's number is now 4 to the power n by root pi, right? Is that it? Yeah, 4 to the power pi, yeah. Okay, root pi, and then now this is gamma of n plus half by gamma of n plus 2, right? And then now what I can do is I can now try to write it in terms of beta function, right? So for that, I just need gamma a, gamma b by gamma a plus b, right? Because then it becomes beta a comma b, yeah. So the central binomial, this Catalan's nth Catalan's number becomes 4 to the power n by root pi, and then gamma of n plus half, gamma of 3 half by gamma of n plus 2, and then also gamma 3 half, right? So now this becomes this nth Catalan's number will be 4 to the power n by root pi, and we know that this is just root pi by 2, right? And over here this is now beta of n plus half comma 3 half, right? So now I almost have the integral now. This is now 2 times 4 to the power n by pi, and that's the beta function, integral from 0 to 1. So first of all, t to the power n plus half minus 1, and then 1 minus t to the power 3 half minus 1 dt. So nth Catalan's number is 2 by pi 4 to the power n, integral from 0 to 1. This is n minus half 1 minus t to the power half dt. So we already have an integral representation, right? But we want to take it to the form that we are interested, right? Now we can try to transform this integral into the two different forms that we have over here. The second one is actually quite easier, so let's do that first. The second one, what I need to do is, I just need to take this 4 to the power n inside, and that becomes 40 to the power n, t to the power minus half, 1 minus t to the power half dt, right? And this now becomes 2 by pi, integral from 0 to 1, 40 to the power n. Now this becomes 1 minus t by t to the power half, right? Now if I make a substitution that x is equals to 40, then I'm gonna have this nth Catalan's number is 2 by pi, integral from 0 to 1, x to the power n, and then t is x over 4, so 4 minus x by x to the power half, and then dt is dx over 4, right? So this is dx over 4. And so we see that this becomes 1 over 2 pi, integral from 0 to 1, x to the power n, 4 minus x by x to the power square root dx. So 1 over 2 pi square, integral from 0 to... Wait. Okay, when I make substitution, this goes from 0 to 4 now. I'm sorry. So integral from 0 to 4 x to the power n, and then square root of 4 minus x by x dx. Okay. So yeah, we got one of this, right? Now again, to get the another integral expression, we take the same integral and then try to modify it in different way. Okay. So we take the same expression and try to modify it differently. This time we want to make sure that there's this t to the power 2, right? So what I'm gonna do is, I'm gonna make a substitution that t is equals to u square. Okay. So this becomes 2 over pi 4 to the power n, integral from 0 to 1 again. So this time it should be 0 to 1. And u to the power 2n minus 1, 1 minus u squared to the power half, and dt is 2u du, right? So this becomes now 4 over pi 4 to the power n, integral from 0 to 1, u to the power 2n, 1 minus u square root, right? This u basically multiplied with u to the power 2n minus 1, so we have u to the power 2n du, right? Now because the integrand is even, I can actually use the 2 in front to make it go from minus 1 to 1, u to the power 2n square root of 1 minus u squared du. And that's exactly the integral we are given, right? Yeah, 2 over pi 4 to the power n from minus 1 to 1, u to the power 2n square root of 1 minus u squared du. So yeah, we have derived both the expressions now. And basically this was the major expression that gave us both of this, right? And that's how we actually derived this, right? So the main thing was basically to be able to write the central binomial coefficient in terms of the gamma function, right? And after that it was easy. After that it was just like we transformed that to beta function, which is already an integral expression, and then we got the integral expression. So basically, whenever there's this factorial thing, you try to use beta gamma function to take it to integral and then make simplifications. So that's what we did in this video as well. And I hope you enjoyed this. And later on, it was just some new substitutions. So I think this gives you a new problem solving technique to basically change factorials to integrals. And that can actually be quite helpful at times. So do keep that in mind. So this was it for today. I hope you enjoyed the video. Thanks for watching, and I look forward to seeing you in the upcoming videos too.